Hello everyone, welcome back to Anantha Lakshmi Academy. If you are visiting my channel for the first time, please do subscribe to Anantha Lakshmi Academy to follow all the 10th class maths videos. So today we are going to cover exercise 7.1 of coordinate geometry chapter. Even before to this, we have done the introduction video wherein we did a quick recap of coordinate axis, also the distance between the points on x-axis and distance between the points on y-axis and distance between the points on a line parallel to coordinate axis and distance between the points in the xy plane. And now we are here with the exercise problems. Even before this, as I tell you every time, even before starting the exercises, please go through the examples. I hope you have already gone through the examples. If you have not, just pause this video right here, go back to the examples, please go through them and come back to the video, because examples are very important, which give you a clue on how to solve the exercise problems. So pause this video right here. In fact, if you go through the examples, you may not need to go through this video as well. So if you have any questions even after going through the example, please do watch this video further. All right. So the very first problem I have already listed on the board. It has barely 4 bits, out of which I am solving the 4th bit. All right. Wherein they are asking us to find the distance between 2 points. If you observe the coordinates here, they are like x1, y1, x2, y2. All right. Let a is equal to a comma b, b is equal to minus a comma minus b. What is the distance formula that we have learnt in the earlier session? Nothing but distance between 2 points is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Alright, this is what we have learnt. Now let's apply the same formula. So the first one is going to be x1 comma y1. The second one is going to be x2 comma y2. So let's replace those variables here. That is nothing but minus a whole square plus minus b whole square. That is going to be minus 2a whole square plus minus 2b whole square, 4a square plus 4b square under root of 4. If I take common, this is going to be a square plus b square. If I split this one, under root 4 into under root of a square plus b square, this is going to be under root of 4 is nothing but 2 root a square plus b square. Alright, this is nothing but the distance between the points a and b. So AB is going to be 2 root a square plus b square. Alright, that is about the very first problem in exercise 7.1. And the second problem is figuring out the distance between the origin and one more point that you can solve by yourself. So I am not solving that. I am going directly to the third problem, wherein they are asking us to verify if the given points are collinear or not. Collinear, what is collinear? Why I am solving this problem is to tell you what is collinearity. Alright, let us assume 3 points A, B, C. A, B, C are the points lying on the same line. When 3 points lie on a same line, they are said to be collinear. So if you observe this, AB and BC, AB plus BC is nothing but AC. That is nothing but sum of any two distances is equal to third distance. Sum of any two distances is equal to third distance, then the points are said to be collinear. Here any two distances means here AB and BC are equal to AC in the example which I have told you. That is when we call the points to be collinear. So here we will be figuring out, if I say, okay, let me put it as, let A is equal to 1 comma 5. This is the solution. B is equal to 2 comma 3 and C is equal to minus 2 comma minus 1. Alright, so here we are going to figure out AB, BC and AC, and then observe if we like AB plus BC is equal to AC, or BC plus CA is equal to AB, or CA plus AB is equal to BC. If any of that condition succeeds, then these points are said to be collinear. So for that we need to calculate the distances. So that is going to be AB. What is the formula? Under root of x2 minus x1 whole square plus y2 minus y1 whole square. As this is the first time I am writing it, from the next time onwards I will be directly replacing the values, alright. So here AB is nothing but 2 minus 1 whole square plus 3 minus 5 whole square. 2 minus 1 is 1 square is 1, 3 minus 5 minus 2 square is 4. So this is going to be root 5. AB is going to be root 5. So now BC, I am going to calculate BC. BC is nothing but minus 2 whole square plus minus 1 minus 3 whole square. Minus 2 is minus 4, nothing but 16. Minus 1 minus 3 is again 16. This is going to be under root of 32, which can be written as 16 into 2, that is nothing but 4 root 2. Alright, now CA. CA I am going to calculate. So 1 plus 2 whole square, 1 plus 2 whole square plus 5 plus 1 whole square is equal to under root of 3 square plus 6 square, which is nothing but 9 plus 36. 36 plus 9 is 45. 45 can be written as 9 5s are 9 into 5. 9 5s are 45, right? So this is going to be 3 root 5. Now, if we do AB is root 5, BC is 4 root 2, can we get this? CA, no chance. BC plus CA, if you do AB, can you get? No. So, here, okay, let me write it here. In the given problem, the sum of any two distances is not equal to the third distance. Hence, the points are collinear or not? Not collinear. The points are not collinear. Why they are not collinear? They did not meet this criteria of sum of any two distances is equal to the third side. Alright, that is about the third problem. Alright, if you have gone through the examples, you might be knowing about this condition of collinearity. You don't need to go through this problem further. Yes, sir. Okay, that's the reason I keep on stressing on going through the examples. So that is about the third problem. Let me jump into the next problem. So here we have the fourth problem listed on the board. Even before I tell you about the fourth problem, we need to consider few things, like in triangles, especially in the coordinate geometry, when they ask you to figure out these things. If it is a equilateral triangle, if it is a equilateral triangle, given points A, B, C of x1, y1, x2, y2, x3, y3. Okay. What is the condition for equilateral triangle? AB equal to, all three sides should be equal, right? CA. Okay. Now, when it comes to the next type of triangle, isosceles triangle. In case of isosceles triangle, any two sides should be equal. AB equal to BC, or BC equal to CA, or AC equal to AB. Any of the condition, any one of the condition, okay, one of the condition should be meeting. And since it is said as isosceles triangle, sum of any two sides, meaning any two lengths, sides or lengths, should be greater than the other side or other length. Okay, that is about triangles. And when we are drilling about quadrilaterals, why am I telling you all this is because all the questions in this exercise are like, check whether this forms a square, check whether this forms a equilateral triangle, check whether this forms an isosceles triangle, like this. So that's the reason I am giving you conditions. So if it is a square with points x1, y1, x2, y2, x3, y3, x4, y4. Okay, if it is a square, then you need to have AB equal to BC equal to CD equal to DA, which means within a square all sides are equal. Also, the diagonals are equal. ABCD. Sorry, ABCD. For a square, all the four sides are equal and also the diagonals. And next comes rhombus. Rhombus also, all the sides are equal, but one of the diagonal is equal to 2 times the other diagonal. AC is equal to 2BD. The longer one is 2 times the shorter one. And then comes the parallelogram. And then comes the parallelogram, wherein this is how its structure is. A, B, C, D. Here, opposite sides are equal. AB is equal to CD and BC equal to AD. And diagonals are not equal. Okay. Take a screenshot of this, because from point number 4 till point number 10, you need to figure out whether it is a square or a rhombus or a parallelogram or a isosceles triangle or equilateral triangle. So that's the reason I gave you all these conditions. All these conditions, we just have to figure out the distance and show that this is what all the sides are equal and diagonals are equal, hence this forms a square. All the sides are equal, one diagonal is equal to double the other diagonal, and hence this is a rhombus. And opposite sides are equal and the diagonals are not equal, hence this is a parallelogram. Like this we have to prove. Okay, for this one isosceles triangle I am going to solve now. For rest of the problems, depending upon these conditions, you could solve them by yourself. If you are not able to solve this or your answer is not matching with the textbook answer, please do write in the comment section so that I could solve in the later videos. Alright, so let me jump into the fourth problem of this exercise. Let A is equal to 5, minus 2. Here we are asked to prove if these are the points or the vertices of a isosceles triangle. If you look at the right side of the board, what did I give the conditions for isosceles triangle? Either of these three conditions should be matching, like any two sides should be equal and sum of the two lengths is greater than the third length. Okay, for that let us We know distance formula. Distance between 2 points is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Alright, this is what we have learned. So let's draw this AB length first. So 6 minus 5 whole square plus 4 minus of minus 2 whole square. This is going to be 1 square 1 plus 4 minus of minus 2 is plus 2. 4 plus 2 6 is 36. 6 square is 36 and this is going to be 37. Now let me try drawing out BC. Okay, this is going to be 7 minus 6 whole square plus minus 2 minus of minus 4 whole square. Minus 2 plus 4 is going to be, okay, 7 minus 6 is 1 plus minus 2 plus 4 is 2 square. Yeah, minus 2 plus 4 is 2 square is 4. This is going to be root 5. And then we have CA, which is nothing but CA. 5 minus 7 whole square plus minus 2 minus of minus 2 whole square. 5 minus 7 square is 2 square. There is nothing but 4. Minus 2 plus 2 gets cancelled. This is going to be 2. Four plus 2 6 37. 7 minus 6 1 minus 2 minus. Okay, here BC is not minus of minus 4. Minus 2 minus 4 is, this is 36. Okay, this is nothing but 37. BC I took minus 4th. Okay, so that's the wrong thing which I did. Okay, so this is going to be root 37. If you see here, AB equal to BC. AB equal to BC and AB plus BC is 2 root 37 is AB plus BC is greater than AC. Therefore, the given points form an isosceles triangle. Dot. Alright, the given points form an isosceles triangle. Here I assumed it as minus 4 and I corrected it later. Okay, so that is about 4th problem. In the next problems till 8 or 9, you can use these conditions to solve them. So I am not going to solve them. That is about this video. So if you like the content, please do like, share and subscribe to Anantha Lakshmi Academy. Also refer this to any of your 10th class students or any of your 10th class relatives if you know any. Thank you for watching.